Good morning, 5B. This is Mr. Wong. Today is the 17th of April, Friday. Alright, first part we will go through yesterday's homework, which is activity 5.2 and page 9 and 10 of your electrical system SIN. And after that, today we'll move on to electrical conductors and electrical insulators, and then I'll give you some work after that. Alright, so let's start the ball rolling. Let's go through activity 5.2. Okay, right, in activity 5.2, I actually want you to do this activity with the help of the online software. Alright, you can't do this at home because you don't have the materials for it. So make sure you use your online software, which I'm going to show you later, to construct the circuit and then to see whether the bulb lights up. So if the bulb lights up, put a tick. If not, you can put a cross. Okay, it is fine. So we have all these circuits that we want to try. So I'm going to go through some of them, and I'm going to go through the rest that I've not gone through and see whether it works. Okay, so I'm going to use the software. So let's go over to the software first. So for A, I've tried yesterday already. So I've shown you how is it done. A will not light up because the metal casing is not connected to the battery at all. So now we'll continue with B and the rest. So for B, let's construct the circuit. So it looks like a battery. I'll turn the battery over like this, put it in the center. Great. Then after that, I have a bulb on top, connect them, and then I have a wire coming from the negative terminal all the way to the metal casing. So I have a wire, metal casing, and I'm going to join them both. 3, 2, 1. Yes, it works. Okay, you can see the current, if electric current is flowing through, it's a closed circuit, the bulb lights up. So for B, for circuit B, the bulb lights up. So I'm gonna put a tick for B. Okay, B, the bulb lights up. Okay, now we will explore C. Let's go back to the software. So to break this up, all you need to do is to cut it up. Okay, so for C, something different. Now the battery is still here, of course, but the bulb is lying down and is touching the positive terminal with the metal casing. So I'm gonna turn this like this. So the metal casing touch the positive terminal and the wire coming from the uh, negative terminal to the metal casing. So maybe I'll turn this over to this side. Okay, like this. And go higher. Come over here. Now I'll put another wire to connect it to the metal casing, which is here. Right. So you realize this is circuit C, battery, metal casing touching the positive terminal, and then a wire coming from the negative terminal all the way to again the metal casing. So you realize it does not light up. Okay, is a open circuit. Why? Because the metal tip is not connected. So for circuit C, the answer is no, it will not light up. Okay, no, it will not light up. Okay, circuit D, let's try. Okay, I'm gonna break this up, or it's not even connected in the first place. I'm gonna break this up. Circuit D, now the bulb is on the negative side, negative terminal. So I'm gonna turn the bulb one big round, something like that. Connect to the negative end of the battery, and then I have a wire running from the positive end of the battery to the metal casing. So let's do this, something like that. Okay, let's move it over here, connect. Okay, and then from the metal casing, I'm going to connect to here. 3, 2, 1. Realize the circuit is closed. It's a closed circuit. Electric current is flowing through. Bulb lights up. Okay, so even when the bulb is connected to the negative terminal, as long as the metal tip is connected to the battery and there's a wire coming from the positive end of the battery to the metal casing, it works because the circuit is closed. So yes, for circuit D, it works. Okay, circuit E we tried yesterday already, so I won't go through that. Let's go on to circuit F. So for circuit F, let's remove this. Let's remove this also. Let's remove this also. Put this aside. Put this away first. Okay. going to turn it the other way around, connect it to the positive end, and then now the wire actually comes from the negative terminal and then all the way to the glass part, the glass bulb. Okay, so I don't need this, to the glass bulb. So connecting to here. Does it work? No, it doesn't work because why? The wire connects to the glass, which is a insulator, and you will learn it's not a complete circuit. As you see, touches the glass, which is a insulator, which you will learn later. So this one, light bulb doesn't light up, it doesn't work. So for F, it doesn't work, doesn't light up. Okay, two more. Let's go for G. Okay, so move this aside. G is very special. Okay, so let me just cut this away. The bulb is on the side, but now instead of one wire coming from the positive, one wire coming from negative terminal, both wires are coming from the positive terminal. I'm going to put this over here, drag it aside first. I need two wires for this. This wire I'll return back. Don't need this wire anymore. Right, so I want to have wire going to the metal casing from the positive end. I want a metal going from the positive end to the metal tip. And then let's see, 3, 2, 1. Nothing happens. Okay, the reason why, because the negative end is not connected. The electric current can't flow through the battery. So if you're just connecting it to the positive terminal, the bulb does not light up. So for G, the bulb does not light up. And for the last one, for circuit H, let's disconnect this, let's disconnect this, let's disconnect this. Alright, so what you have is actually a battery, a wire connected to it. There's a bulb over here which we saw, and it's connected to the glass bulb. Once again, you know glass bulb is a insulator. And after that, I have a metal wire, and then it joins to the metal tip. Put it here, join to the metal tip, something like that. You realize that the bulb doesn't light up. Why? Because once again, oh no, it doesn't go to the metal tip, sorry, it goes to the glass bulb as well, which is very weird. Okay, so I'm going to put it here, I'm going to drag it, I'm going to put it like this. Okay, so this is circuit H. You realize that the positive and negative end of the battery is connected, but both wires is connected to the glass part, which is an insulator, which does not conduct electricity. So again, there is a gap, it is an open circuit. Okay, so no, circuit H does not work, does not light up. Alright, so what I want you to do is for I, which you have done yesterday, I want you to draw another circuit which the bulb lights up. This one should light up. Okay, this one should light up. Okay, so I'll be looking at your class cake. I will give you my comments. I'll tell you it's right or wrong. Okay, if it's wrong, try again. Make sure that you can get it correct. Okay, but perhaps to just show you another method that is not shown here. Okay, and this method is the most straightforward. Okay, it's not that difficult. So let me just show you an example of it. So it's a very standard way of connecting, nothing new. Okay, so let's say I'm connecting to my bulb over here. Use another wire. I'm gonna connect it like this. Come over here. I'm not gonna use a switch because the activities doesn't mention about switch. Something like that. Okay, so this is a very standard way of connecting, which is not shown in the circuits in the book, but this is just a very simple way of doing a closed circuit. Okay, so you can copy this down, draw the battery, draw the wires, draw the bulb, and this is how it should look like. Okay, so you can do this for I, but I'll look at your answer and I'll mark it. All right, So when I'm done, I'll tell you about it. So now let's go back to Classkick. Okay, so let's full screen this already. Alright, so what happens that for the last part, the conclusion, bulbs that light up, you will see a pattern. Okay, bulbs that light up are in circuit. Which circuits do they light up in? They light up in circuit B, D, and E. Okay, B, D, and E. Okay, so circuits B, circuits D, circuits E, they light up. The bulbs light up. There are different ways to form a closed circuit, and we know we need a closed circuit to make sure the electric current flows, make sure that the bulb lights up. So bulbs in a closed circuit will light up, while bulbs in a open circuit will not light up. Okay, so closed circuit, complete circuit, electric current will flow, you will light up. Bulb open circuit, there's a gap, electric current cannot flow, will not light up. Okay, simple as that. Alright, let's go to the SIN, page 9 and page 10. Alright, so from yesterday's lesson, we know that a switch can be used to close or to open the circuit. So here you realize that the switch is closed, and when the switch is closed, you can actually trace the flow of electric current, because the electric current can flow from the positive terminal to the bulb through the switch which is closed and then form a complete loop. So when the electric current forms a complete loop, is what we call a closed circuit. Means the electric current can flow, means the light bulb can light up. Okay, so with that, the light bulb will light up because first there's a battery as the energy source, and the switch is closed. Okay, this is what we call a closed switch, the on position. Okay, closed, the switch is closed, and when the switch closed, the circuit is a closed circuit. Okay, on the other hand, now we go on to the next circuit. You realize now the circuit is actually open. The circuit is open. So let's say if I want to trace the flow of electricity, start from the positive end, I go to the bulb, I get stopped here because there's a gap over here. And once there's a gap, the electric current cannot flow through, the bulb does not light up, so the bulb will not light up. Okay, so the bulb will not light up because the switch is open. Forming an open circuit. Okay, simple as that. Right? So there are two ways to connect a bulb to a battery. In each diagram, draw a wire to such that a closed circuit is formed and the bulb light up. So now there's a one wire missing. So I'm gonna use my pencil. I'm gonna draw the wire out so you can see how we make the bulb light up. So realize the positive end is connected to the metal tip. Okay, current can flow through the filament down to the metal casing. So I will connect from the metal casing, which is here. I will connect to the negative end. Okay, so what happens here, if you trace the flow of electricity, it can go up from positive end to the metal tip, to the filament, down to the metal casing, and then back to the negative terminal, and then the whole cycle repeats again. For this, on the other hand, it is bulbs connected to a positive end. So let's say the flow of electric current from the positive end, it will go to the metal casing, go up to the filament, come down to the metal tip. So I will draw from the metal tip to the negative end of the negative terminal of the battery. So what I have here is a complete circuit so that the bulb will light up. Alright, so just make sure that it is a complete loop touching both the metal casing and the metal tip, right? You want the bulb to light up. Right, so last page. Alright, so these cases the bulb will not light up, and why? So if you realize that for part A, the metal tip is not connected to the circuit, that's why it does not light up. Okay, on the other hand, for part B, if you realize the metal casing is not connected to the metal tip, it is still an open circuit. Okay, and for the last one, you will see that, hey teacher, the circuit is fine, the positive end is connected to the metal casing, goes up to the filament, comes back down to the tip, it goes to the negative end, and then it seems perfectly fine. But why doesn't it light up? Because sometimes when we use too many batteries, when there's too much electric current flowing through the circuit, okay, when there's too much electric current flowing through the circuit, it makes the filament melt because it's very hot. So what is the keyword here? The bulb, what we call the bulb is the bulb actually blew, or the bulb blows, or the bulb actually fused, means melted. Okay, so when we put too many batteries together and we put just one poor little light bulb there, too much electric current flow through the filament, it will blow, it will fuse, it will melt. Okay, so this is the homework for yesterday. Today we'll be looking at electrical conductors and insulators, and we'll be doing activity 5.3 again using the online software. I will guide you through as well in the next video. See you later.